Good day, class. We are looking at Intermediate Algebra Practice 2 for Module 2. Covers Chapter 4, Systems of Equations and Inequalities, Chapter 5, Polynomials and Polynomial Functions. The first question deals with systems of equations and inequalities. So if the system of linear equation results in two parallel lines, the system is, if the system of linear equations result in two intersecting lines, we want to know what type of a system we have. And also, if the system of linear equation results in a single line, what type of a system we have. Okay, so to deal with that, let's recall what we covered in our PowerPoints. Consistent system with independent equations. The system has a single solution at the point of intersection. The graphs are different, they have different slopes. Here's an example. Here's the graph, they have different slopes. Any two lines that are intersecting, okay? So the two intersecting lines, this part, the answer is a consistent system with a unique solution. Inconsistent system, the system has no solution. The graphs are parallel lines, they have the same slope, but different intercepts. Here's an example. The graph clearly indicates two lines that are parallel. M1 is equal to M2, but B1 is different than B sub 2. That means they have different y-intercepts. So two parallel lines, we are dealing with the inconsistent system. Finally, and of course, if we were to solve this by the method of elimination or substitution, it results in a contradiction such as 0 equals 7, 2 equals 5, things of that nature. Consistent system with dependent equations, the system has an infinite number of solutions, the graphs are identical. In other words, we really have a single line. They have equal slopes, equal intercepts, and right away, that is this last part, a single line. That means a dependent system. Also, if you were to solve that, what happens is you end up with an identity, such as a true statement, such as 0 equals 0, 5 equals 5, so on and so forth. This is question 2. Similar to question number 2, we have a system to solve. Minus x plus 2y equals negative 1. 5x minus 10y equals 6. Notice if we multiply the first one by 5, we can get rid of the variable x. By the way, the idea behind the elimination method is to eliminate, okay, a variable, okay? So if we multiply this by 5, the second equation doesn't change, but the first equation changes to what? Minus 5x plus 10y equals negative 5. Notice, when that happens, if we add them up, minus 5x and 5x cancel each other. They give us 0. In this case, it so happened that these two also cancel each other. So the left side is 0. Now we add up the right side and we expect to get something maybe similar to 0 and so forth, but the answer doesn't happen. When they are different, what does it mean? That means we've encountered a false statement. It's a contradiction. We are dealing with parallel lines with no solutions. It's an inconsistent system, class. It's an inconsistent system. In the second case, you first decide what variable to get rid of. If, for example, you want to get rid of x, okay, you're going to multiply, let's say, the first one by 5, the second one by 2, notice, because you want the coefficients of x to undo each other. If you want to get rid of the y, you can multiply the first one by 3, the second one by 7, okay? Because they do have different signs, you don't have to multiply by a negative, okay? So if we do that, if we multiply the first one by 3 and the second one by 7, let's see what happens. So this one gives us 6x minus 20y equals 9. And this one gives us minus 35x plus 21y equals 7 times 7 is 49. And so the y's have coefficients that cancel each other. And so we end up with 6x and negative 35x. We add those two up and we get negative 29x. We add up 9 and 49, we get positive 58. If we divide by 2, x becomes negative 2. Now, you have to go back to one of the original equations. For example, let's say the first one. So 2 times x, 2 times negative 2, minus 7 times y equals 3. 2 times negative 2 gives us negative 4. We move it to the right side, and that results in 7. Therefore, y equals negative 1. It's a good practice to write the answer in pairs, okay, so it becomes clear what we are dealing with. This is also a similar question to 2b, a system of equation involving 3 variables. We follow the same methodology, the elimination method. And so we have to first figure out what we want to get rid of, the x, the y, the z, you decide. And this is really not too bad. You can choose any of them. Notice in the first equation, and I'm going to give it a number here. So this is equation 1, 2, and 3. We just call them by numbers because it makes it easier to deal with that. Therefore, if I add the first one and the second one, I notice that 4y and negative 4y cancel each other. So I'm going to put those two together just the way they are without any changes and get rid of the y variable. So equation 1 and equation 2, when we add them up, let's see what we get. 3x and 2x is 5x. These two cancel each other, okay? 2z plus z is 3z, and negative 15 and 16, they add up to positive 1. So we have that. Now, because we got rid of the y variable using these two, now we're going to continue. We must use the third equation because it hasn't been used, and one of the first two equations, and get rid of the same variable, namely y. Okay, so we are going to use this equation. We have no choice because it hasn't been used. Okay, and if we use the first equation, okay, we multiply the first one by 3 and the third one by 4. Let's see what happens. We're going to multiply this one by 3. Okay, 9x minus 12y plus 6z equals minus 45. By the way, this is the what I have in mind. Okay, so that would be the equation. And this one, we are going to multiply by 4, giving us 8x plus 12y plus 20z equals 80. Okay, so equation number 1, we multiply by 3. Equation number 3, we multiply by 4. And so what happens? These two cancel each other. So 9 and 8, 17x, 6 and 20 plus 26z. When we add up the right side, we get positive 35. So now look at this equation and look at this equation. These two give us the new system. Both involve the x variable and the z variable. We decide to get rid of either x or z, okay? And so just for the sake of argument, if you want to get rid of the x, you can multiply this one by 17, this one by 5, one of them negative, okay? Because you want to undo the sign. If you want to get rid of the z, you multiply this one by 26, this one by 3, one of them negative, okay? So for example, If we multiply the first one by 17, we get 85x plus 51z equals 17. So if I'm multiplying by 17, that means I'm trying to get rid of the x. Now this one, I want to multiply by 5, but this time negative, okay, because I want to undo that. So I'm going to multiply by negative 5, which results in negative 85x minus 130z minus 175. Now if we combine these two, 85x, negative 85x cancel each other, we have to add these two. 51z minus 130z gives us negative 79z, and then 17 and negative 175 gives us negative 158. So what happens next? Divide by negative 79. Z becomes 2. We go to one of the original equations. If we had two variables, but we don't, we have only one variable. So we go either to equation 4, or this one, if we want to give it the equation 5, for example. Let's in fact call this equation number 5. Okay, and so equation number 4, 5 times x, which we don't have, plus 3 times z, which we have it to be 2, equals 1. Okay, and of course this is 6. You take it to the other side, becomes minus 5 divided by 5, x becomes negative 1. So what we have so far is negative 1, y is missing, and z is equal to 2, and all you have to do, choose one of the original equations and come up with the y. I'm going to leave it for you to do that. And after you come up with the answer, you must check with the other two equations to be on the safe side. I can't emphasize this enough. Okay. Here's a system of inequalities we want to solve. We did inequalities previously. Now we are looking at a system. So we are going to do them one by one, and we're going to follow the simple step of coming up with the boundary line by writing equality for both cases. We need a couple of points for the first one, the intercepts. And we need a couple of points for the second one. I highly recommend the intercepts because they give us better graphs, more precise graphs. So we are going to do that. If we let x be 0, okay, y becomes negative 2. That's one pair. If we let y be 0, x becomes 1, 1, 0 for the first one. We do the same thing for the second one, and they result in the following pairs. Therefore, we can graph the first line with those two pairs. This is the y-intercept, this is the x-intercept class. Okay. So we have 0, negative 2, 1, 0. That's the line. We have 0, 3, 2, 0. That's the blue line. Okay. Now, before we move on, we should notice, of course, this has the equality, this one doesn't, okay? The one with the equality is the blue line, and it's a solid line. This one doesn't, so this has to be changed to a dashed line, okay? So you change it to a dashed line because of that. Now that you did that, you pick a test point for each case and you check it out. So since 0, 0 is not included in any of those lines, that would be a best choice and the easiest choice. So you have to choose 0, 0. You can choose any number that is not, any pair that is not on the line. And so You try this for the first one, and you try it for the second one. In other words, if you plug in 0, for the first one, you get 0 is less than 2, which is a true statement. For the second one, you get 0 larger than or equal to 6, which is a false statement. So this is the point we are going to use. And here's the case. Let's see what it means. If you look at the red one, 0, 0 works, okay? That means this is, if it was a single inequality, this is the side that you are going to accept and shade. So for the red one, this will be shaded. For the blue one, the line blue one, 0, 0 results in a false state. This side, including 0, 0, is not acceptable. So the opposite side will be shaded. And we're going to put the whole thing together. So again, the red line, this side, blue line, this side, when they are shaded, it creates 4 regions. This is the region that the red and blue come together. So that is your solution, everybody. That is your solution, this region. Very straightforward. We've seen the same question. We want to solve it through this system of equations. A chemistry lab assistant, 1 in 10 liters of 48%, that's its solution. And we have 80% and 40%. So how many of each we should mix to come up with the mixture of interest? This is a mixture problem, as I said in the previous case when we went over this type of question. A class of problem called a mixture problem. We need to come up with the following table, and we are going to write what is given first and foremost. And so we have 80% solution, that means 0.8. You can keep it as 80% or 0.8, 40% solution or 0.4. The mixture will be 48% or 0.48. What about the volume? Under the volume, 10 is given because we want 10 liters of 48%. Okay, what is missing? Well, the volume for the first one and the second one is missing. So we say X amount, that means X liters. If I want to be more precise, I would put liters here. Okay, everybody. So X liters for the first one, Y liters for the second one. Again, we just don't know, we come up with those. The pure amount of acid, or the actual amount of acid, is the percent that we have times the volume. So the pure amount of acid, if something is 80%, gives us only 0.8x. This one gives us 0.4y, and this one gives us 0.48 times 10. So that's what we get. And this gives us the first equation, x plus y equals 10. And this last column, 0.8x plus 0.4y equals 4.8, gives us the second equation. Now we have a system of equations we can solve. And to solve this, basically we go with the substitution method. Is easier because in this case, y, for example, is 10 minus x, and replace it. Now we're going to replace this one with 10 minus x. Right side, of course, is their product, which is 4.8. We are going to distribute the 0.4. It results in 0.8x is unchanged. 0.4 times 10 is 4, minus 0.4x equals 4.8. We are going to combine these two. Into 0.4x. We are going to subtract 4, and we end up with 0.4x equals 0.8 divide by 0.4, x becomes 2. That means 2 what? 2 liters. And obviously, the first equation is easier to use to find the y, which becomes 10 minus 2 equals 8. We write x equals 2 liters of what? 80% solution. Y is equal to 10 minus 2 equals 8 liters of 40% solution. Needless to say, you must check. How do you check? With the second equation. You must check with the second equation. A plane can travel 800 miles per hour with the wind and 720 miles per hour against it. We want to find the speed of the wind and the speed of the plane using systems of equations. Let P represent the speed of the plane and W represent the speed of the wind. By the way, we can go with X, Y, any variable of your choice. In a simple case like this, I highly recommend you stick with the initials. When we go in the same direction as the wind, or in the water, the current, the speed of the wind, the speed of the current will be added to our speed and they will help us. On the other hand, if we go against the wind or against the current, they will work against us. So a plane can travel 800 miles per hour with the wind. So P plus W is 800 and P minus W is 720. It's against that. So it's really a simple setup. There's not much to it. You don't even have to do any changes. Just use the elimination method, add up the left side, and W and negative W cancel out. You get 2P, and the right side, 800 and 720, they add up to 1520. And now you divide by 2. And you have the speed of the plane, 760 miles per hour. Put this into any of those original equations, the first or the second one results in the speed of the wind being 40 miles per hour, and check it with the second equation. So for example, over here, if this is 760 plus what number is 840, and of course 760 minus 40 is 720. So that makes it straightforward. Admission tickets to Braden River Leather League All-Star game cost $4 for adults, $1.50 for children. We have a total of 225 tickets and $500 in hand that we have collected. We want to know how many tickets and how many children, how many adult tickets and how many children's tickets that were sold. Again, believe it or not, it's a kind of problem known as a mixture problem. So having said that, again, let's set it up just the way we did the previous one. So adults, it's going to cost us $4, and children is going to cost us $1.50 per ticket. How many we have? Total of 225 tickets. How much money do we have? Total of 500. Now, we can go X and Y, or maybe even the initial. A represents the number of adults, C represents the number of children. It makes it easy to remember what they are. Otherwise, you have to be very precise and very careful as to how you define your variables. So the total amount would be 4 times A for the adults, 1.5 times C for the children. Therefore, we have the first equation, A plus C equals 225. Second equation for A plus 1.5 C equals 500. Again, you can do it by any method, substitution method, elimination method. For example, if we multiply this one, if we keep this intact and we multiply this one by -4, we can get rid of the A. So -4, that is -4A, -4C, -4 times 225 is -900. Just write the second equation intact. These two cancel each other. What about these two? They add up to -2.5 C, and they add up to -400. Okay, you divide by negative 2.5. And I hope you realize it's the same as 4,000 divided by 25. Okay, 100 divided by 25 is 4. 4 times 40 makes it 60. So that's the answer. And all you have to do, go to the first equation. It's easier. And replace the C with 160. And A becomes 65. A becomes 65. So it really can't get any easier than that. And of course, you check with the second equation to be on the safe side. To move on to the next topic, I want to refresh your memory about exponential rules. Zero exponential rule, product rule, power rule, again, sort of a power rule, okay. Quotient rule, okay. If you have a parenthesis to the power of and everything gets powered up. Negative exponential rules, these three are all negative exponential rules. Notice what happens. If you have a negative exponent, you just move it, okay. Up goes down, down goes up. If you happen to have a negative after the parentheses, you just flip it over. Then we go with the general review of factoring. So let's see what is the synopsis of that. When it comes to factoring, your first step is GCF, the greatest common factor. As always, you should always look for that. After that, then you look at the number of terms. How many terms do we have? 4 terms. We go factor by group. Normally 4 terms. We may even have more, in which case we go also by group. If we have 3 terms, what happens? Well, do we have a perfect square? A squared plus 2ab plus b squared is a plus b squared. A squared minus 2ab plus b squared is a minus b quantity squared. If it's not a perfect square, if it's in this form, x squared plus bx plus c, we want to find 2 factors such that the sum is b and the product is c. Okay. X plus the first times x plus the second. If a is not equal to 1, there are several methods. You can go with the trial and method or find 2 factors, AC, sum is b, and write these factors as coefficient of 2 like terms that when combined equal bx, and then factor by grouping. You can look at more details in my PowerPoints. And I've also given you the third method. I highly recommend you look at that. That in some instances make life a lot easier. If you have 2 terms, we have a difference of squares, we have to memorize that. A squared minus b squared is a plus b times a minus b. Do we have a sum of cubes? A cubed plus b cubed, we have to memorize that. A plus b times a squared minus ab plus b squared. A difference of cubes, a cubed minus b cubed, that means a minus b times a squared plus ab plus b squared. And of course, you can check by the reverse process. Let's look at a few examples, starting with this. Okay, so I want to mention the order of operations. So you can go with the parentheses and change this to 9, or you can realize the separation takes place with the negative and positive sign. So this one separates from this one, separates from this one. Okay, and so this is minus 2 squared is 4. This is minus 2 cubed is 8, plus 4 times 3 squared is 9, and then plus 9. So minus 4 minus 8 plus 4 times 9, and negative 3 quantity squared is 9. This 2, the product is 36. 4 times 9 is 36. So you have minus 4 minus 8 plus 36 plus 9. They add up to 33. Very simple. Order of operations. Part B, it's being raised to the power of 0. The result is 1. 1. The result is 1. All right. We are looking at number 7. Again, we're going to do the order of operations. The very first thing is to change 3 to the power of -1 as 1/3 minus, now these two we can combine them in the following manner, class. The base is 4. We use the product rule, so we add up their exponents, -2 and +3, they add up to 1. So let's quickly recap, see what we did. So 4 is intact, division is intact, 3 to the power of -1 becomes 1/3, and these two give us -4 to the power of 1, which is simply 4. So now order of operations, we do the division first. Division by 1/3 means multiplication by 3 over 1. This is the same as 4 times 3 over 1, or 4 times 3. So 12 minus 4, and the answer is 8. Okay, again, pretty straightforward. So let's look at the next one. There are several ways of handling this equation, this expression. You can simplify the inside first and apply the -1. You can apply the -1 first. It really makes no difference if you go back and look at your exponential rules. As long as you're comfortable with them, anything will work. So here's what's going to happen. So if we apply the -1, this becomes a to the power of -4. The b cancels out. We don't have to do anything. We just get rid of the b's because they're identical. Okay. First and foremost. Okay. And then c to the power of -2 times -1 is +2. And this one, a to the power of -3 times -1 is x to the power of +3. And c to the power of 2 times -1 is -2. So we got rid of b, and this is what happens. Now, remember, we want a positive exponent. So how do we move this? This has a negative exponent, we bring it down. This has a negative exponent, we bring it up. So this moves up, this moves down. Now this, the numerator is c to the power of 4, the denominator is a to the power of 7. 2 plus 2, 3 plus 4. We are using the product rule. Part B, the answer is -4. There's really not much to it because -4 to the 3rd power is -64. When you have an odd index, positive comes out as positive, negative comes out as negative. We don't want to mix them up with what's coming up later on with complex numbers and the idea of I. All right. For part C, let's apply the 2. That means the power rule. So 2 squared is 4, x squared, y to the power of 3 times 2, 6. We do the same thing here. X to the power of 2 times 3 is 6, y to the power of -3. So let's write that. And now we see how we are going to simplify this. First and foremost, these two cancel each other, and they give us x in the denominator. This one comes up as y cubed, and with y to the power of 6 becomes y to the power of 9. Okay. And number 4, of course, is intact up there. It's not going anywhere. Part D, flip it over to the power of +2. This is one of the properties we discussed, and therefore 9 over 4. What is the degree of each polynomials? Well, this is in descending order. So this is the leading term, and the degree is clearly 3. What happens when you have two variables? Okay, if the variables are being multiplied, as you can see in this case, they are being multiplied, then you add up their exponents. In this case, the exponent is 2 plus 2 equals 4 is the largest. So this is 3, and this is 2 plus 2 equals 4. I want you to know, yes, this is x cubed. This is the largest with respect to x, but with this case, okay, 2 and 2 will be added because they are being multiplied. Okay, class? We want to factor completely. We went over the synopsis of factoring, and here's the special factoring that you need to know. And so the very first thing you need to notice in the first example, you have two terms. And so what you should do is very simple. So notice this is 2x cubed. This is 3 cubed. So we are looking at a cubed plus b cubed. So you can locate a cubed plus b cubed where a is 2x and b is number 3. So basically replace it here. So a plus b, 2x plus 3. Then a squared, that means 2x squared. Minus ab, that means minus 2x times 3 plus b squared, that means plus 3 squared. So we are looking at this one. Now simplification, this is done. This one changes to 4x squared. This one to minus 6x. This is plus 9, and you're done. Part B, we're going to do the same thing. This is a cubed minus 2b quantity cubed. So we are looking at a cubed minus b cubed. A is a, and b, replace the b with 2b here. Replace, anywhere you see b, replace it with 2b. So a minus b becomes a minus 2b. A squared plus a times b becomes a times 2b, and b squared becomes 2b quantity squared. Okay, so this one is 2b quantity squared. This is a times 2b. All right, the next one, x to the power of 4 minus 5x squared minus 36. Again, you may see the easy way out by noticing that x to the power of 4 is x squared times x squared. So if you go that route without the substitution, you should be able to handle this. And notice you want two numbers. The product is c, or negative 36, and the sum is negative 5, which makes it 4 and 9, one of them negative. Okay, it's important to understand. You want 4 and 9, so what you're really looking at is negative 36, and you say, I want one of them to be negative, and for example, 4 and 9. Of course, there is more, there are more pairs, but 4 and 9 will do the job. And you will ask yourself, which one would be negative? You look at the middle term and you say, you want negative 5, right? Because you want negative 5. If you choose minus 4 and positive 9, they add up to positive 5. So you have to choose positive 4 and negative 9. Now, anytime you do the factoring, you want to look at it one more time. Am I done, or do I need to go further? And in this case, x squared minus 9 is not a finished job. It is x minus 3 times x plus 3 in any order. We are looking at a squared minus b squared. The next one, D, again, it's 9. If you want, you can rewrite this as 9 squared minus z squared to the second power. So you're looking at, again, a squared minus b squared, which becomes 9 minus z squared, 9 plus z squared. And the first one follows the same format again, 3 minus z, 3 plus z. And the last one is unchanged, class. I want you to know that the last one does not change. Okay, so the last one remains intact. It's extremely important to see that. Okay, so having said that, we are ready for the next set of examples. All right, 4x squared minus 12x minus 16. What is the very first step? The first step is GCF if there is any. And I hope you realize number 4 is in common. So we take it out. Now it becomes easy. We want two numbers. The product is -4, the sum is -3. So we get 4 times x minus 4, x plus 1. This, by the way, you can write it in any order. You can write x plus 1 times x minus 4. We continue with the same thoughts. Step 1, GCF. 2 is in common, x is in common, y squared and y is in common. I hope you see that. And you divide this one by the first one, gives you y. Divide this one by the common factor, gives you 3x z, and there's nothing we can do to further simplify this. Well, we see 1, 2, 3, 4 terms, and therefore some sort of a grouping is in order. We try this. If it works, it's fine. If not, then maybe we go with the first and the third, first and the fourth until it works out. So if we look at the first two, what can we take out? The first two, A is in common. And when you take the A out, you get A times A plus 3. Remember what you want to do. You want to do the same thing here such that you get a common factor. So you can take out 2, or better yet, -2. Because if you take out -2, it gives you the same common factor of A plus 3. So how do you finish the job? You write A plus 3, and then whatever is left, including its sign. Notice, from here we have A. From here we have -2. This is how you finalize the job. Okay. Now, for the last question on the page, you have a couple of choices. You can just simplify and do the math, okay, by raising this to the second power and so on and so forth. But that's really not a good practice. The best practice would be to use the substitution by letting p minus 5 be equal to any variable of your choice except p. So let x represent that and rewrite it as 6x squared plus 11x plus 3. Now you want to factor this, and it's really not too bad. There are 3 different methods. Again, I've discussed that in my PowerPoint. You can go back to it. But this is fairly easy because 3 is a prime number. I mean, you have no choice but to go with 1 and 3. You just have to split the 6 into 2 pieces, 1 and 6 or 2 and 3. So by trial and error, you do this. What is important for you to see this, the product of these two, which is 9x, the product of these two, which is 2x, they must add up to this middle term of 11x. That's why it's called trial and error. Now, we would be done if we weren't interested in p, but p is given. We must replace the x with p and do the elementary algebra of simplifying it. So we just apply the 2. We get 2p minus 10 here. We apply the 3, we get 3p minus 15 here, and we combine the terms, and we end up with the following. Okay. 2p minus 7 times 3p minus 14 is the last answer. By the way, because of the substitution we did, we must look at it one more time in case there's a common factor here you take out, there's a common factor here you take out. We don't have any. Now we want to solve by factoring. So let's see how it's done. The very first step is to make sure everything is on one side when you want to solve by factoring. This is, so let's go with a GCF of 4x. Now we want two numbers. The product is -12. The sum is +1. This is 4x. Don't forget the x is here. Therefore, x is 0 because of this, -4 because of this, +3 because of this. And you're done. In the second part, part B, if you will, you have to bring to the same side first. So this is x squared minus 12x, and when we move it becomes plus 20. Now you want two numbers, the product is 20, the sum is negative 12. This results in x equals 2, this results in x equals 10. Okay. We want to subtract this expression from this expression. So you're going to write this one first minus this one second. So it's important to write it properly. Distribute the negative sign. So the first three don't change. Positive x squared minus 3x minus 5 put together 4x squared and x squared as 5x squared. Minus 6x and minus 3x, they add up to negative 9x, and the numbers, they add up to negative 3, and that's the final answer. Let's multiply. So we multiply these two. So 4 doesn't change, x squared becomes x cubed. It's important to see that this one doesn't have an exponent. That means the exponent is 1. Y doesn't have an exponent. The exponent is 1. So x squared changes to x cubed. Y cubed changes to y to the power of 4. We do the same thing here. 4 times minus 20 is minus 80. X to the power of 2 plus 5 is 7. Y to the power of 3 plus 7 is 10. If you multiply by the last piece, negative 2 and 4, the product is negative x, negative 8. X squared y cubed, and y is y to the power of 4. And I have them in different colors so we can compare and contrast. I hope you remember the a plus b squared. So a squared, 2x squared. So let me just write this underneath. So we have a squared plus 2 times a times b plus b squared, and well, the order this is done, I'm doing part B before C, my apologies. So let's just quickly look at part B and finish the job. Again, I put them in different colors. Just multiply the 2x and then multiply the plus 1. And I suggest you put them in descending order. It really is helpful. 6x cubed, there's nothing else you can add up. Negative 2x squared and positive 3x squared, they add up. They add up to x squared. 4x and negative x, they add up to 3x. And this is your final answer. As I was saying for part C, and I'm going to remind you, although I just mentioned that a plus b squared is a squared plus 2ab plus b squared. That's what we are using here. And we just rewrite the answer, 4x squared. You don't have to take this step. You can do it in your head. Okay, square this one is 4x squared. 2 times the first times the last is 20x, and 5 squared is 25. The next question is asking for the intercepts. In order to find the x-intercepts, you must set y equal to 0. I hope you remember that. To find x-intercepts, set y equal to 0. So we're going to set the y, or f of x, the function, equal to 0 and solve. And to do that, we factor by starting with the GCF, okay? Among those three, the GCF is 3x. So number 3 is in common, also x is in common. So we end up with 4x squared minus 13x plus 10. And we factor this by any of those methodologies that have been discussed. The trial and error will always work. You just want to be careful. Again, the way you do it, you want to make sure this middle term, minus 5x, this middle term, minus 8x, they add up to what we had here, negative 13x. That's really the part you want to be careful, because coming up with 4x and x, minus 5 and minus 2 is not a big deal. For example, you may have even positive 5 plus and positive 2. Those two work, but it is the middle term you want to be careful of. So you set each one equal to 0. This means whether you say x is 0 or 3x equal to 0 makes no difference. So x is 0. 4x minus 5 is 0, x is 5 over 4. X minus 2 is 0, x equals 2. So one more time, 3x or x equal to 0 gives you 0. 4x minus 5 gives you 5 over 4, x minus 2 gives you 2. Now, it is important to know what that means. X-intercepts, okay? Remember, y is 0. You set y equals 0 to solve. Let's write all of this in pairs such that the y coordinate is 0. So this means the following 3 pairs. And I highly recommend you write the 3 pairs because you really want to know the meaning of your work here. What do we mean when we say x is 0, x is 5/4, x is 2? We mean we have the following 3 pairs on the graph of this function, y equals 12x cubed minus 39x squared plus 30x. That's the meaning of it. One leg of a right triangle is 4 centimeters less than the other. The area is 70 square centimeters. We want to come up with the length of each leg, and we want to set up a system of equations. So this is a right triangle class. Okay, one leg is, let's say, x, and one leg, let's say it's y. And of course, the units, centimeters. Okay, now, one leg is 4 centimeters less than the other. So which one is less? This one is less, right? Okay, so you can say x is y minus 4. That's the meaning of the first sentence. Okay, because x is less than y clearly in our drawing here. Doesn't matter which one you write as long as you define it. So the way we have it, x is less than y, so therefore this is the equation. The second equation is the area. I hope you remember the area is 1/2 base times the height. So the area is 1/2 base times the height. In any right triangle, one leg is considered the base, one leg is considered the height. And so with that being the case, x is y minus 4, half of base times the height, half of x times the y is 7. And generally speaking, we don't want to use fractions. So to solve this system, first we get rid of the fraction. How? Multiply by 2. Since this is given in the format that the substitution can be easily used, we are going to use the substitution by replacing the y, the x with y minus 4. X is y minus 4. Let's do that. We are going to solve this. When we distribute, we get y squared minus 4y. And remember, when we want to solve, we bring everything to the same side. So minus 140 equals 0. We want two numbers. The product is negative 140 and the sum is negative 4. So those are fairly simple. Negative 14 and positive 10 will do the job. Okay. Again, notice 10 times negative 14 is negative 140, positive 10, negative 14, they add up to negative 4, okay? So it's 10, which means y is either 14 or negative 10. However, dimensions can't be negative. Because they can't be negative, this negative 10 is out. It's no longer acceptable, okay? So the only acceptable answer, y is equal to 14 centimeters. And if you subtract 4 from it, you get the x. So x must be 10 centimeters. So the dimensions are x is 10, y is 14. And if you multiply the two, divide by 2, you get the 70 square feet as its area. So it does work. I hope you see that why it does work. Division. We want to divide those, and anytime we have one term in the denominator, one term, then we cut this into so many fractions. Because the numerator has 3 terms, we cut it into 3 fractions. And we do this one by one. I hope you see that the 3 cancels each other. So we end up with x squared y to the power of 4. That would be the first one. Minus 12 cancels out 3. That gives us 4. X cancels out x, and y becomes y to the power of 9. This one, everything cancels out. We get minus 7. So again, step 1, make up 3 fractions. Step 2, simplify one by one. Okay, very simple. And with the same thing with the variables. All right, now that we have x plus 3 in the denominator, we can do long division, also synthetic division. So let's go with long division and see how it's done. All right. The way the long division works, you write it in this fashion, and just the way you divide numbers, okay, and again, I have that explained in my PowerPoints, you sort of guesstimate when we do the numbers. So how do we do that here? We look at only the first terms, the first term here, the first term here, okay? And so here's the first term of the dividend. Here's the first term of the divisor. So we divide this one by this one, only these two to begin with. So this one, we divide by this one, and that gives you x. Then what do? You multiply this by the whole thing here, every term of the divisor. So times this one is x squared, times this one is 3x, and you subtract from the top. So x times x is x squared, x times 3 is 3x. Now this must be subtracted from the top. Okay. So minus x squared, these two cancel each other. Then minus x. Now remember, this is now being subtracted. So this is negative 3x, and negative x, the result is negative 4x. We can bring down the negative 13. And we do the same thing again. We are going to divide the first term by the first term, which results in negative 4x divided by x is negative 4, and we put it up here. Now we're going to multiply the negative 4 by every term in the divisor. So negative 4 times x is negative 4x, negative 4 times 3 is negative 12. And we are going to subtract this from the top. Okay, so this becomes positive 4x, they cancel each other. This becomes positive 12 with negative 13, they give us negative 1, which means here's the quotient, here's the remainder. Quotient, remainder. So how do we write that? We can write it two different ways. Here's one way. You write the quotient, and then whatever the sign is, since it's negative, you're going to put minus, or you can put plus and put negative 1 up here. So minus 1 over the denominator. So this is one way to write that. I mean, if you left it as that, that really has the same meaning, but I want to make sure we understand what happens here. And finally, the second method is to say the numerator is the product of x plus 3, the quotient, the divisor, and x minus 4, the quotient. And we add the remainder, including its sign, which means we subtract 1. So x squared minus x minus 13 is x plus 3 times x minus 4 in any order, and add the remainder, which is negative 1.